There are places in the universe that seem to call to us, not with sound, but with silence, with mystery, with the promise of discovery. Mars is one of those places. A world that has danced across our night skies for millennia, glowing red with the fire of ancient myth and modern science. It is not the closest planet to Earth, nor the largest, but it is the one that has always felt reachable, familiar, and now, perhaps for the first time, it is within our grasp. To the ancients, Mars was divine, a celestial warrior. The Babylonians tracked its motion across the heavens, and the Romans named it after their god of war. To the astronomers of the Renaissance, it was a puzzle. Its retrograde motion defied simple explanation, and its wandering path helped shape our understanding of planetary orbits. Mars was not just a point of light, it was a challenge to our intellect. In the 19th century, the telescope revealed more. Giovanni Schiaparelli described canali, channels, that sparked imaginations. Percival Lowell believed they were canals, built by a dying civilization to carry water from the poles. The idea was wrong, but the dream endured. Mars became a canvas for speculation, a world that might be alive, or at least once was. Then came the age of machines. In 1965, Mariner 4 flew past Mars and sent back the first close-up images. What it revealed was not a world of canals, but of craters. Cold, desolate, lunar. Yet even in its barrenness, Mars held secrets. In 1976, the Viking landers touched down and searched for life. They found none. But they found weather, dust storms, frost, a planet that was not dead, but dormant. The robotic age of Martian exploration had begun. Spirit and Opportunity landed in 2004, expected to last 90 days. They lasted years. They found evidence of ancient water, minerals that form only in its presence. Curiosity followed, a mobile laboratory that drilled into rocks and analyzed their chemistry. And now, Perseverance roams the Jezero crater, searching for signs of ancient microbial life. Each rover is a scout, a messenger, a whisper from Mars, "I was once alive." And so we ask, if Mars was once alive, could it be again? Could it host life, not Martian, but human? This is the question that defines our age. Not just whether we can go to Mars, but whether we should. Whether we are ready to become an interplanetary species. Because Mars is not just a destination. It is a mirror, a test, a challenge to our ingenuity, our resilience, and our imagination. To stand on Mars and look back at Earth, a pale blue dot hanging in the blackness, would be to see our world as it truly is, fragile, singular, and shared. It would be a moment of profound perspective. A moment when the story of life on Earth expands to include another world. We are the cosmos made conscious. And for the first time, that consciousness is preparing to step onto another planet. Mars is waiting. And the journey has already begun. Before human footprints can press into the ochre soil of Mars, machines must first leave their tracks. For decades, our robotic emissaries have journeyed across the void, touching down on a world that once flowed with rivers and now whispers secrets through stone. These machines, silent, tireless, and exquisitely engineered, have become our eyes and hands on a distant planet. They are not merely tools. They are explorers. The robotic age of Martian exploration began with a whisper. In 1965, Mariner 4 flew past Mars and sent back the first close-up images. What it revealed was sobering: a cratered, seemingly lifeless world, more like the Moon than the Earth. The dream of canals and civilizations faded. But something else emerged, a sense of scale, of possibility. Mars was not alive, but it was real, tangible, reachable. In 1976, the Viking landers became the first to touch the surface. They carried instruments to search for life, to analyze soil, to study the atmosphere. They found no definitive signs of biology, but they did find weather, frost, dust devils, a planet with seasons and rhythms, a planet that was not dead, but dormant. Then came the rovers. Spirit and Opportunity landed in 2004, twin explorers designed for a 90-day mission. They lasted years. Opportunity, in particular, roamed for nearly 15 years, traversing plains, climbing hills, and peering into craters. These rovers discovered hematite, an iron-rich mineral that forms in water. They found clay deposits. They revealed a Mars that was once warm and wet, a world that may have been habitable. Curiosity followed in 2012, a mobile laboratory the size of a small car. It drilled into rocks, analyzed their chemistry, and found organic molecules, building blocks of life. It measured radiation levels, helping us understand the risks future astronauts will face. It climbed Mount Sharp, layer by layer, reading the geological history of Mars like chapters in a book. And now, Perseverance roams the Jezero crater, a place once filled with water. It carries the most advanced suite of instruments ever sent to another planet. It is searching for biosignatures, chemical traces of ancient life. It is collecting samples that may one day be returned to Earth. And it has a companion, Ingenuity, a helicopter that flies in the thin Martian air, proving that powered flight is possible on another world. These machines are more than marvels of engineering. They are storytellers. Each wheel rotation, each drill sample, each panoramic image is a sentence in the unfolding narrative of Mars. They have shown us riverbeds and deltas, sedimentary layers and mineral veins. They have revealed a planet that was once dynamic, perhaps even alive. But they have also shown us the limits of machines. No rover can feel the texture of Martian soil between its fingers. No drone can look up at the sky and feel awe. For all their brilliance, these machines are proxies. They are preparing the way for something more profound, the arrival of human consciousness on another planet. When the first astronauts step onto Mars, they will do so with the legacy of these machines beneath their boots. They will walk in the tracks of Spirit and Opportunity, drill where Curiosity drilled, and perhaps even retrieve the samples Perseverance has cached. They will be explorers, yes, but also inheritors. Mars is a world that has waited patiently, and our machines have listened. They have mapped, measured, and marveled. They have endured dust storms and freezing nights. They have died with dignity, their final transmissions echoing across space. And now, they pass the torch. Mars is beautiful, stark, silent. A world sculpted by ancient rivers and shaped by eons of wind and dust. But it is not kind. To live on Mars is to confront a landscape that is both alien and unforgiving, a place where the rules of Earth no longer apply. And yet, we are preparing to go. Not merely to visit, but to stay. To survive. to build a new chapter of human history on a world that has never known life as we do. This is not science fiction. It is a challenge of biology, physics, and engineering. It is a test of our ability to create life in a place where life does not belong. Mars has an atmosphere, but it is a ghost of Earth's. Composed mostly of carbon dioxide, it is less than 1% the density of our own. The surface pressure is so low that liquid water cannot persist. The air cannot be breathed. The wind cannot be felt. It is a world where the sky is thin and the silence is absolute. Temperatures swing wildly. At the equator, on a summer's day, it may reach a modest 20 degrees Celsius. But at night, it plunges to -90 degrees Celsius. At the poles, winter temperatures can fall below -125 degrees Celsius. The planet is cold, but not uniformly so. It is a place of extremes. And above all, there is radiation. Mars lacks a global magnetic field. Its atmosphere offers little protection. Cosmic rays and solar particles bombard the surface, posing a serious threat to human health. On Earth, we are shielded. On Mars, we are exposed. To survive, we must build cocoons of Earth. Habitats that are sealed, pressurized, and shielded. Structures that mimic the conditions of our home planet, down to the last molecule of oxygen. These habitats may be inflatable modules covered in regolith, or rigid structures buried beneath the soil. They must be airtight, thermally regulated, and capable of withstanding dust storms that can last for weeks. Inside, life support systems must recycle air and water with extraordinary efficiency. Every breath, every drop, must be accounted for. Water can be extracted from the Martian soil, which contains hydrated minerals and subsurface ice. Oxygen may be produced from carbon dioxide using electrolysis, a process already demonstrated by the MOXIE experiment aboard Perseverance. Food will be grown in hydroponic farms, nourished by artificial light and recycled nutrients. This is not just engineering. It is ecology. A closed-loop system where waste becomes resource, and survival depends on balance. Mars has gravity, about 38% of Earth's. It is enough to keep us grounded, but not enough to prevent the physiological effects of long-term exposure. Muscles weaken. Bones lose density. The cardiovascular system adapts in ways we do not yet fully understand. Astronauts aboard the International Space Station exercise for hours each day to counteract the effects of microgravity. On Mars, similar regimes will be required. Resistance training, cardiovascular workouts, perhaps even artificial gravity in rotating habitats. The human body is adaptable, but it is also vulnerable. We must learn how to live in a gravity that is neither Earth nor space, but something in between. Perhaps the greatest challenge is not physical, but psychological. A crew on Mars will be isolated, millions of kilometers from Earth. Communication delays of up to 22 minutes each way mean that real-time conversation is impossible. There is no rescue, no return without months of preparation. They will live in confined spaces, under constant stress, with the same few people for years. The monotony, the isolation, the sense of distance, all must be managed. Mental health will be as important as oxygen and water. History offers lessons. Antarctic researchers, submarine crews, astronauts aboard the ISS. We know how to endure. But Mars will demand even more. Survival is not enough. We must design for humanity. Habitats must be more than functional, they must be comforting. Spaces that nurture the mind as well as the body. Light, color, privacy, and connection will matter. Art may matter. Music, conversation, the rituals of daily life. Because to live on Mars is not just to endure, it is to begin again. To create a new culture in a new world. To survive on Mars is to perform a delicate ballet of science and spirit. It is to build Earth in miniature, to shield ourselves from a universe that does not care whether we live or die. It is a triumph of knowledge, of engineering, of imagination. But it is also a reminder that life is rare, that Earth is precious, that survival is not guaranteed, even on our own planet. Mars will test us, but it will also teach us about resilience, about interdependence, about what it means to be human. And if we succeed, if we build a home in the dust, it will be one of the greatest achievements in the history of our species. To reach Mars is to cross an ocean, not of water, but of space. A gulf so vast that light itself takes minutes to traverse it. A journey that transforms astronauts into interplanetary sailors, navigating the gravitational tides of the solar system. It is a voyage unlike any in human history, and it begins with fire. At its closest, Mars lies 55 million kilometers from Earth. At its farthest, over 400 million. The planets dance around the Sun in elliptical orbits, and the timing of our departure must be precise. Launch windows open roughly every 26 months, when Earth and Mars align favorably. Miss the window, and the journey becomes longer, more expensive, more perilous. The path we take is not a straight line. It is a curve, a Hohmann transfer orbit, that spirals outward from Earth and intersects Mars. It is the most efficient route, but it is slow. Using current propulsion systems, the journey takes 6 to 9 months. For that time, astronauts will live in a spacecraft that must be more than a vessel. It must be a sanctuary. The spacecraft that will carry humans to Mars must protect them from the void. It must shield them from radiation, provide artificial gravity or counteract its absence, recycle air and water, and offer psychological comfort. It must be a home, a laboratory, and a lifeboat. NASA's Orion capsule, SpaceX's Starship, and other proposed vehicles are being designed with these challenges in mind. Starship, in particular, envisions a fully reusable spacecraft capable of carrying dozens of passengers and cargo to Mars. It is a bold vision, one that echoes the great ships of exploration from Earth's own history. Inside, astronauts will face microgravity for months. Muscles weaken. Bones lose density. The cardiovascular system adapts in ways we do not yet fully understand. Exercise regimes, dietary supplements, and perhaps even artificial gravity through rotation may be required to keep the crew healthy. Space is not empty. It is filled with radiation, cosmic rays from distant galaxies, solar particles from our own star. On Earth, we are shielded by our magnetic field and atmosphere. In deep space, we are exposed. Radiation shielding is essential. Water, polyethylene, and even Martian soil may be used to line the walls of spacecraft and habitats. But shielding adds mass, and mass is the enemy of propulsion. Every kilogram must be justified. Every gram must serve a purpose. Communication with Earth will be delayed. At its farthest, signals take over 20 minutes to travel each way. Real-time conversation is impossible. Autonomy becomes essential. Crews must make decisions without waiting for instructions. They must be scientists, engineers, doctors, and diplomats, capable of solving problems in isolation. Landing on Mars is a challenge unlike any other. The planet's atmosphere is thick enough to cause heating during entry, but too thin to slow a spacecraft effectively. Parachutes alone are not enough. Retrorockets, inflatable decelerators, and supersonic parachutes must work in concert. NASA calls it the 7 minutes of terror, the time between atmospheric entry and touchdown, when the spacecraft must slow from thousands of kilometers per hour to a gentle landing. There is no room for error. No second chance. Once on the surface, the journey continues. Pressurized rovers will carry explorers across the plains. Drones will scout terrain. Habitats will be assembled. Science will begin. Returning from Mars is not guaranteed. The journey back requires fuel, timing, and a second launch window. Some missions may be one way. Others may stay for years. The logistics are complex, but the principle is simple. We must be able to leave, or we must be prepared to stay. To cross the cosmic ocean is to redefine exploration. It is not a voyage of conquest, but of curiosity. Not a race, but a revelation. It is a journey that demands our best, our science, our courage, our imagination. And when we arrive, when the first human steps onto the surface of Mars and looks up at the Earth, a pale blue dot hanging in the sky, it will be a moment of profound perspective. A moment when the story of life on Earth expands to include another world. We are the cosmos made conscious. And now, that consciousness is preparing to sail across the stars. To explore Mars is to survive it. But to remain, to build, to thrive, is something altogether more profound. It is the difference between a footprint and a foundation, between a visit and a civilization. And to make that leap, we must bring with us not just courage, but tools. Tools that transform a hostile world into a habitable one. Tools that turn dust into shelter, air into breath, and isolation into opportunity. Mars will not be conquered by brute force. It will be tamed by elegance and innovation. On Earth, we build with abundance. On Mars, we must build with scarcity. Every kilogram launched from Earth costs energy, money, and risk. The solution is simple in principle, but revolutionary in practice. Use what Mars provides. This is the philosophy of ISRU, In Situ Resource Utilization. It is the art of turning Martian materials into human necessities. The Martian atmosphere is rich in carbon dioxide. Using electrolysis, we can split CO into oxygen and carbon monoxide. The MOXIE experiment aboard Perseverance has already demonstrated this process. It is a small step, but it points to a future where astronauts breathe Martian air, not directly, but through transformation. Water can be extracted from subsurface ice and hydrated minerals. Once obtained, it becomes not just a source of hydration, but a feedstock for fuel. Hydrogen and oxygen, split from water, can power rockets. Mars may one day provide the fuel for our return. Regolith, the dusty soil that covers the planet, can be sintered into bricks, melted into glass, or used as radiation shielding. It is not just dirt. It is a building material. Mars is cold, and its sunlight is weak. Solar panels work, but they are vulnerable to dust storms that can last for weeks. The solution may lie in redundancy, solar arrays paired with batteries, backed by compact nuclear reactors. NASA's Kilopower project envisions small fission reactors that can provide reliable energy for habitats, rovers, and life support systems. These reactors are designed to be safe, scalable, and long-lasting. They may become the beating heart of Martian settlements. Wind power is unlikely. Geothermal is uncertain. But nuclear and solar, in tandem, offer a path forward. Mars is vast. Its surface area is equivalent to all the continents of Earth combined. To explore it, we must move. Pressurized rovers will allow astronauts to travel tens or even hundreds of kilometers across the surface. These vehicles must be robust, insulated, and capable of supporting life for days at a time. They are not cars. They are mobile habitats. Drones, like the Ingenuity helicopter, will scout terrain, map routes, and search for resources. Autonomous systems will monitor equipment, manage power, and respond to emergencies. Artificial intelligence will not replace humans, but it will amplify them. Navigation will be local. GPS does not exist on Mars. Instead, we will rely on orbital satellites, inertial systems, and visual landmarks. Every journey will be a mission. Every step, a calculation. Mars is far. Signals take between 5 and 22 minutes to travel each way. Real-time communication is impossible. Delay-tolerant networks must be developed, systems that store, forward, and prioritize data intelligently. High-gain antennas, relay satellites, and laser communication may offer faster, more reliable links. But autonomy will remain essential. Crews must operate independently, with Earth as a distant advisor, not a constant companion. Habitats must be modular, scalable, and resilient. They may begin as prefabricated units, expanded with inflatable modules, and eventually evolve into structures built entirely from Martian materials. Radiation shielding is critical. Regolith, water, and polyethylene may be used to line walls. Underground habitats may offer natural protection. Thermal regulation must balance the extremes of day and night. Airlocks, pressure suits, and emergency systems must be flawless. Inside, life support systems must recycle air, water, and waste. Hydroponic farms will grow food. Waste will become fertilizer. Every system must be closed-loop, every resource reused. Mars will not be mastered by a single technology. It will be sustained by a symphony, a network of interdependent systems, each supporting the others. Energy powers life support. Life support enables exploration. Exploration finds resources. Resources sustain energy. It is a delicate balance. A dance of engineering and ecology. And it must be robust enough to endure failure, flexible enough to adapt, and elegant enough to inspire. The technologies we develop for Mars will not remain on Mars. They will shape life on Earth: clean energy, closed-loop agriculture, autonomous systems, and resilient architecture. Mars is not just a destination. It is a crucible for innovation. And as we build the tools of a Martian future, we are also building the tools of a terrestrial renaissance. To walk on Mars is to walk into isolation. It is to step beyond the reach of real-time conversation, beyond the safety of rescue, beyond the rhythms of Earth. It is not just a physical journey, it is a psychological odyssey. And it will test not only our technology, but our humanity. Mars is distant. At its farthest, it lies over 400 million kilometers away. Signals between Earth and Mars can take up to 22 minutes each way. A question asked may not be answered for nearly an hour. In this delay, something profound happens. Autonomy becomes necessity. Astronauts must become decision-makers, problem-solvers, and caretakers of one another. They will live in confined habitats, surrounded by a landscape that is both magnificent and barren. The Martian horizon stretches endlessly, yet the walls of their shelter will be close. The paradox of space exploration is this: the farther we go, the smaller our world becomes. Survival on Mars is not just about oxygen and water. It is about meaning. It is about connection. The habitats we build must not only protect the body, they must nurture the mind. Light matters. Color matters. Privacy matters. A window, even if it looks out onto a lifeless plain, can offer perspective. A shared meal, a moment of laughter, a message from home, these are not luxuries. They are lifelines. Designing for humanity means understanding that we are not machines. We are emotional, social, and imaginative. We need stories. We need rituals. We need beauty. We have glimpsed this reality in the extremes of our own planet. In Antarctic research stations, where scientists endure months of darkness and isolation. In submarines, where crews live in confined quarters beneath the sea. In the International Space Station, where astronauts orbit in a fragile bubble of life. These environments teach us resilience. They teach us the importance of routine, of exercise, of mental health support. They teach us that isolation can be endured, but only if it is understood. Mars will be harder, longer, farther, but it will not be impossible. Purpose is the antidote to isolation. When astronauts look out at the Martian landscape, they will not see emptiness. They will see history, geology, possibility. Every rock may hold a clue to ancient life. Every sample may rewrite our understanding of the cosmos. This sense of mission, of contributing to something greater than oneself, is powerful. It transforms hardship into honor. It turns solitude into significance. And it is not limited to astronauts. The entire endeavor of Mars exploration is a collective act of imagination. Engineers, scientists, artists, and dreamers all contribute to the tapestry. It is a human story, written across disciplines and generations. In the silence of Mars, relationships will matter more than ever. Crews must be chosen not just for skill, but for compatibility, for empathy, for humor, for the ability to listen, to forgive, to endure. Conflict is inevitable, but so is camaraderie. The shared experience of living on another planet will forge bonds that are deeper than distance. It will create a new kind of family, one born not of blood, but of purpose. To live on Mars is to redefine what it means to be human. It is to carry our consciousness to another world. To bring with us not just science, but spirit. Not just survival, but soul. We will not be the same. The first humans to return from Mars will carry with them a perspective that cannot be taught. They will have seen Earth as a distant dot in the sky. They will have felt the fragility of life, the vastness of space, and the strength of the human spirit. And they will remind us that exploration is not just about reaching new places. It is about becoming new people. Exploration has never been safe. From the first ocean voyages to the edge of the known world, to the astronauts who rode fire into orbit, every step beyond the familiar has carried risk. And yet, we go. Not because it is easy, but because it is necessary. Mars is no exception. It is distant, hostile, and indifferent to our survival. But it is also beautiful, ancient, full of questions we have not yet learned to ask. To reach Mars is to accept danger. To live there is to embrace uncertainty. And to thrive is to understand that risk is not the enemy of progress, it is its companion. The voyage to Mars begins with launch. Rockets are complex, volatile machines. They carry tons of fuel, accelerate with immense force, and must perform flawlessly. A single malfunction can end a mission before it begins. Once in space, astronauts face microgravity, radiation, and isolation. The human body is not designed for long-duration spaceflight. Muscles atrophy. Bones lose density. The cardiovascular system adapts in unpredictable ways. Radiation from cosmic rays and solar flares poses a constant threat, and shielding is imperfect. The spacecraft itself must be resilient. Life support systems must recycle air and water without failure. Power systems must endure. Communications must persist across millions of kilometers. There is no room for error. No margin for complacency. Mars is notoriously difficult to land on. Its atmosphere is thin, too sparse for parachutes alone, yet thick enough to cause heating during entry. The descent must be choreographed with precision: heat shields, supersonic parachutes, retro-rockets, and sometimes sky cranes. NASA calls it the 7 minutes of terror, the time between atmospheric entry and touchdown, when the spacecraft must slow from thousands of kilometers per hour to a gentle landing. During this time, the crew can do nothing but wait. The outcome is determined by engineering, physics, and fate. Once on the surface, the risks continue. Mars is cold. Its atmosphere is unbreathable. Dust storms can last for weeks. Radiation is ever present. Habitats must be airtight, thermally regulated, and shielded. Life support systems must operate flawlessly. A single leak, a single power failure, could be catastrophic. Medical emergencies pose a unique challenge. There is no hospital, no evacuation. Crews must be trained in advanced medical procedures and carry equipment for surgery, diagnostics, and trauma care. Telemedicine is limited by communication delays. Autonomy is essential. Psychological risks are equally profound. Isolation, confinement, and distance from Earth can erode mental health. Depression, anxiety, and interpersonal conflict must be anticipated and managed. The human spirit is resilient, but it is not invincible. Mars is a pristine world. It may harbor ancient life, or even microbial life today. Our presence risks contamination, both biological and chemical. Planetary protection protocols must be followed, balancing exploration with preservation. There are also ethical questions about crew selection, mission duration, and the possibility of one-way journeys. Who goes? Who stays? Who decides? And yet, despite all this, we go. Because exploration is not a luxury, it is a defining trait of our species. We crossed oceans, climbed mountains, and left footprints on the moon. Each time, we expanded the boundaries of what it means to be human. Mars offers more than scientific discovery. It offers perspective. To stand on another planet and look back at Earth is to see our world as it truly is, fragile, singular, and shared. It is to understand that borders are illusions, that our differences are dwarfed by our common origin. Mars also offers hope. The technologies we develop, clean energy, closed-loop life support, autonomous systems, will benefit Earth. The lessons we learn about sustainability, resilience, and cooperation will echo across generations. And perhaps most profoundly, Mars offers continuity. A chance to ensure that life, this rare, precious phenomenon, does not remain confined to one world. A chance to become a multiplanetary species. Risk and reward are not opposites. They are partners. To explore is to accept danger, but also to embrace possibility. To reach for Mars is to reach for a future that is larger than ourselves. We are the cosmos made conscious. And consciousness, by its nature, seeks to understand, to venture, to endure. Mars is waiting. And the risks we face are not signs to turn back, they are signs that we are on the edge of something extraordinary. There will come a moment, perhaps sooner than we imagine, when a human will stand on the surface of Mars and look up at the sky. And there, suspended in the blackness, will be a tiny blue dot. Earth. Home. Everything we have ever known. To see Earth from Mars is to see it as it truly is, fragile, singular, and shared. It is to understand, in an instant, that borders are illusions, that conflict is trivial, and that life, this rare, precious phenomenon, is worth protecting. It is a moment of profound perspective. A moment that will redefine what it means to be human. We are the cosmos made conscious. Through us, the universe has begun to understand itself. And now, that consciousness is preparing to step onto another world. Mars is not just a destination, it is a mirror. A place where we will confront our limitations, our ingenuity, and our identity. To live on Mars is to expand the boundaries of human experience. It is to carry our stories, our cultures, our dreams across the void. It is to become, for the first time, a multiplanetary species. This is not a conquest. It is a continuation. A new chapter in the story of life. The first footprints on Mars will not be the achievement of one nation or one generation. They will be the culmination of centuries of curiosity, collaboration, and courage. They will echo the footsteps of Galileo, Newton, Einstein, and every child who has ever looked up at the stars and wondered. And they will leave behind more than marks in the dust. They will leave habitats, laboratories, and perhaps one day, cities. They will leave a legacy of exploration, of resilience, and of hope. Mars will become a place of science, of art, of community. A place where humanity begins again, not in opposition to Earth, but in harmony with it. Imagine standing on the Martian surface at dusk. The sky fades to a deep, burnt orange. Phobos and Deimos rise, two tiny moons, tumbling across the heavens. And then, just above the horizon, a faint blue star appears. That star is Earth. It is the cradle of life, the birthplace of consciousness. And from Mars, it is small, vulnerable, beautiful. This view will change us. It will remind us that we are one species, sharing one world, with one future. It will inspire us to care more deeply, to think more broadly, and to act more wisely. Mars is not the end. It is the beginning. A stepping stone to the outer planets, to the stars, and perhaps one day, to other forms of life. It is a test of our ability to endure, to adapt, and to imagine. And it is a reminder that we are part of something vast. That our lives, though fleeting, are connected to the rhythms of galaxies and the birth of stars. That our choices matter, not just for ourselves, but for the universe that gave rise to us. The Red Frontier is not just a place. It is a promise. A promise that we will continue to explore, to learn, and to grow. That we will carry the light of consciousness into the darkness, and illuminate new worlds with understanding. Mars is waiting. And when we arrive, we will not be alone. We will bring with us the hopes of billions, the wisdom of generations, and the spirit of a species that dares to dream. We are the cosmos made conscious. And now, that consciousness is preparing to rise over the Martian horizon.